Hello and welcome to your Crystalline Silica for Construction online training. This is training designed by the MECO group for the use of employees who may be exposed to silica dust on the job site. This training is current with the revised standard, the 29 CFR 1926 section 1153, that became enforceable as of September 23rd, 2017. So let's get started. The purpose of this training and all other MECO safety training is to give either initial or refresher training to all employees that could be involved with crystalline silica tasks or materials that contain crystalline silica. Under the standards, we are to designate competent persons in accordance with OSHA and ANSI standards. And remember, a competent person is someone who has the knowledge and skills necessary to identify and recognize a hazard, and then has the authority to do something about it. Like always, our training is employer provided and needs to be effective. It needs to give those the knowledge and skills necessary to perform their job safely. And all of these skills and knowledge and under these training points are found in the 1926 1153. So let's get started. What we're going to talk about today, we're going to talk about some definitions. We're going to go over the standard. Specifically the Table 1 and the alternative methods. We're going to talk about the health hazards of silica, and we're going to talk about the hierarchy of controls and how we want to control and work safely around silica, and then some exposure monitoring, what we're going to do to make sure that you are being provided for. What do we want to learn here today? We want to learn what are the health hazards of silica exposure. What are tasks that expose the silica, and then what the employer has to do and what we do to make sure you're being provided for and putting in a safe environment to protect you from exposure to silica. We already talked about what a competent person is, and then why it's necessary to perform medical evaluations and medical surveillance. So definitions, you're going to hear a couple of these words throughout not only the silica program, but throughout construction standards as a whole, is what is an action level? An action level, when it regards to silica, the action level is the concentrations in which the employer has to do something. Believe it or not, you can be exposed to a certain amount of things and nothing's going to happen. No one has to protect you from it because it's a negligible amount. The unfortunate part is not everyone really knows what that means or what the difference is. But the action level according to silica is airborne respirable crystalline silica particulates of 25 micrograms per cubic meter of air over an 8-hour time-weighted average. Well, what does that mean? Nothing. My goal when it comes to permissible exposure limits and action levels is 0. I don't want to expose you at all, and I'm working very hard to make sure that it's 0. But there is an action level. Remember, we talk about a competent person who's capable of identifying existing foreseeable respirable crystalline silica hazards, so they have the knowledge and skills necessary to identify those hazards. And they have the authority to take corrective action and measures to eliminate or minimize them. When working with silica, you're going to hear the word HEPA a lot. HEPA is not a brand. HEPA is a high-efficiency particulate air filter, and it has to be 99.97% efficient in removing those particulates. That's pretty efficient. So we have to have a HEPA filter when working with silica. What is respirable crystalline silica? Crystalline silica is a common mineral. It's found naturally in the earth. We use a lot of it in construction. We use it in sand and concrete and drywall, bricks. We use pure silica when we put in geothermal wells. Also, the little packets in your beef jerky, that's silica. That's not seasoning. And it doesn't taste good either. We find silica when we're cutting and grinding and demoing and disturb materials that contain silica. And even if they're very small very small particles, those are the respirable, or the ones that can get into our lungs. That's what we're worried about. But when I say crystalline silica, I really mean silicon dioxide. And silicon dioxide is the natural mineral. There's two forms of silicon dioxide. There's crystalline and amorphous. Crystalline is the more hazardous of the two, and of course, that's what we use in the construction industry. But as you can see in the picture, this is what silica looks like. So what does the standard say? Remember the 1926-1153. The standard says we have to limit your exposure. We want to make sure you're not being overly exposed or exposed to levels above the action level or the permissible exposure limit. It gives us two options. We can use Table 1, which we'll look at in a few slides, or the alternative exposure methods. We want to make sure we're using Table 1, and as long as we follow Table 1 to the letter, we can't go wrong. We have to have an established and implemented exposure control plan, which we do. It identifies the tasks that involve the exposure and what we're going to do to protect you from it. It tells us we have to designate a competent person to implement it and enforce it, and that's me. We want to make sure that when we're cleaning up after ourselves, it even tells us how to clean up around silica. We're not going to use compressed air. We're going to use ventilation systems and HEPA filters, and we're going to sweep up after ourselves. But it's not going to be just dry sweeping. The standard also requires us to have medical exams and give x-rays and lung functions tests to make sure that while you're being exposed to silica, that you're not being exposed beyond what's medically safe. And we have to give those to you if you wear a respirator for 30 days or more a year. This training is going to include the health effects of silica exposure and what to look for and the signs and symptoms of what happens when you're exposed to silica, and then keeping records of your silica exposure in medical exams. So Table 1. Table 1 is a pretty inclusive table that has 18 of the more common construction tasks, and looking over it, there's not too much that we do outside that table. And it lays out the effective dust control methods. It tells us the type of tools we have to use and the PPE we have to wear while doing it. It tells us whether or not we have to wear respirators. And if you guys remember correctly from our respirator program and fit tests, the respirators we use do protect against silica dust. If we follow Table 1, we don't have to measure the particulate size. We don't have to see if it's above the action level because we're going to be below it, and that's the point of Table 1. So let's take a look at it real quick. So this is Table 1. This is found in the 1926-1153, and here are the tasks on the very left-hand column. Let's take a look at the first one, using a stationary masonry saw. So the engineering and safe control methods we want to use is we have to use a saw that's equipped with an integrated water delivery system that continuously feeds water to the blade. And then we're going to operate and maintain that tool in accordance with the manufacturer's instructions. If we're using a stationary masonry saw with an integrated water delivery system, we don't have to wear PPE. It says so right there in that column. It doesn't matter. So let's go and look at a walk. Let's see. When you're using a jackhammer. Using a jackhammer, if we're using it outside for less than 4 hours, we don't need to wear PPE, as long as it's got a water delivery system that supplies a continuous stream or spray of water at the point of impact. If we're using it inside, we have to wear a respirator with an assigned protection factor of 10, and that's going to be our respirators. The magic number here is 4 hours. So depending on how long we're using it, depending on what kind of tool we're using, it's going to dictate the type of PPE we wear. And as long as we follow this table, it's going to tell us exactly what we need to do. It's dummy proof. So become familiar with this table, and you can look at the link right here. You can get it from me, or you can Google it, or the program itself should have the table in it. So that's table 1, and we want to make sure we follow that to the letter, because as long as we follow that, we're not going to overexpose ourselves to silica, and we're not going to expose others to silica. However, there are alternative methods. We don't have to use table 1. But if we don't, and we use alternative methods, we have to, and we're responsible for, determining the amount of silica that you're being exposed to. We have to make sure it's not above the action level of 25 micrograms per cubic meter. If it's above the PEL, or permissible exposure limit, of 50 micrograms per cubic meter, we have to protect you guys. We have to give you the PPE and the HEPA filters and everything else, and then use dust controls and provide respirators. The difference is we have to do a lot of the legwork. We have to do a lot of logistical things while using alternative methods. It just makes sense to use table 1. Respirators. We've seen this slide a few times, and every year when we do our fit tests, we understand that we do fit testing with our respirators in accordance with the OSHA standards. We have to give you guys respirators when you're being exposed above the permissible exposure limit, but obviously you guys can wear respirators as much as you like, providing you have that medical evaluation, which you've taken, and that fit test, which I give to you. We don't want to just rely on respirators, though, to protect ourselves. We want to make sure we're reducing and minimizing that dust as much as possible. We use the N100 particulate respirators by 3M. They protect against silica dust. I see on job sites a lot guys using those N95s, and guys, they don't protect against that. Not only that, you have to be fit tested for them, and I don't think a lot of people do. If the wrong person were to come and you're wearing a N95 respirator because you think it's a dust mask, and they, hey, are you fit tested for that? And you say no, that's a $4,500 fine per person if it's our first offense. So we don't want that, obviously. You've heard me say permissible exposure limit, or PEL. What is that? Believe it or not, you can be exposed to certain amounts of things and be just fine. For silica, it's 50 micrograms per cubic meter of air. You can be exposed to that, and technically we don't have to do anything. You're not in danger. But my issue is what is 50 micrograms per cubic meter of air over an 8-hour period? I don't know. Doesn't sound like very much. And then what's the difference between 49 micrograms and 51 micrograms? I don't know either. I'd rather not, risk it. So my goal is for your exposure to be 0. I don't have to worry about, is it 49, is it 50, is it 51? Unfortunately, let's talk about the health effects of silica. And everything about silica kills you. And it doesn't kill you today. It doesn't kill you next week. It doesn't kill you next year. Unfortunately, the effects of silica you might not notice until 25 years down the road, and that's why it's such a big deal now. We've been using silica for a long time, but now we're seeing the silica-related illnesses and fatalities. Much like lead and asbestos, where the stuff works fantastic, and it's the greatest thing since sliced bread, but unfortunately 25 years down the road, hey, this stuff is causing us to die. And now we have to find alternative methods. Now we don't see as much of the lead paint. Now we don't see the asbestos for insulation. So you can probably see in the next 5, 10, 15 years us trying to phase silica out as more and more people come down with silicosis, or a lung disease caused by silica dust, causes inflammation and scarring inside the lungs. Lung cancer, silica has been attributed to lung cancer. Tuberculosis, COPD, pneumoconiosis. These are all lung diseases that prevent us from breathing. And if we can't breathe, well, we sure can't live. You've heard about the hierarchy of controls. I've used this in several of my training. But when I talk about the hierarchy of controls, our first step is elimination. We want to get rid of the hazard. If we get rid of the hazard, we remove the effects. We don't care about the effects of the hazard because it's not there. We don't have to worry about PPE. We don't have to worry about anything else. Unfortunately, we can't always eliminate it. In the construction industry, it's a hazardous industry. We're going to work with this stuff. The next tier is substitution. Replace the hazard, which you'll probably see as us doing throughout the years. It's replacing silica with something that still does the job but doesn't cause lung cancer. Engineering controls is isolating the people from the hazard, and that could be using mechanical devices or clean rooms or robots or ventilation systems. Administrative controls is changing the way people work, monitoring the exposure, limiting their exposure, limiting their time. So if there's silica on the job site, maybe I'm not going to have these guys work 8 hours in this crystalline environment. Maybe I'll have them work 4 and move them somewhere clean, and that way it reduces their exposure. Lastly, and I say lastly because PPE is the absolute last line of defense. It's not a bulletproof vest. It's not a magic pill. It's not a spell. It only mitigates the effects of a hazard once it's already occurred. The goal of the hierarchy of controls is to do everything we can to reduce that hazard before relying on PPE. We still have to wear our PPE, we still have to wear the hard hats and the glasses and the respirators and the gloves, but we want to make sure that the risk to us is minimized as possible. I've added a few things to the hierarchy, and that's housekeeping and hygiene. Housekeeping is cleaning up after ourselves, minimizing that dust using the wet sweeping methods and the HEPA vacuums, and washing our hands before eating, going on break and eating a sandwich, things like that. Housekeeping and hygiene is our personal conduct of keeping the dust out of our lungs. So some safe work practices. In addition to following Table 1, we saw Table 1 was the tools and the PPE. There are some other things we can do when working with crystalline silica. When working in those dusty environments, there's going to be changing areas where you can roll down coveralls and avoid exposing other people. Going home and throwing those dirty clothes in the laundry. Now there's dust in your living room or your bedroom. Blowing yourself off with a pneumatic hose, of course, that's not a great idea. It's going to put all that dust into the air. And using those provided PPE, the Tyvek suits, the gloves, the respirators, utilize those. And not just when I show up on the job site and throw them on real quick to make it look like you're doing what you're supposed to. Washing your hands before taking break or lunch or leaving for the day, cleaning that dust off. And as always, if you don't have to be there, leave. Don't expose yourself if you don't have to be in that area. So let's talk about exposure monitoring and medical surveillance. This is when we know that there is crystalline silica and the potential for exposure. We're going to make sure that you're not being exposed beyond the permissible limits and hopefully not being exposed at all. But as you're doing your work in this atmosphere, we're going to give you initial monitoring. Believe it or not, we're exposed to stuff throughout all our lives. We're exposed to lead continuously. It's way below the PEL, but we're going to make sure that we have a benchmark and see what you're exposed to prior. Make sure that doesn't go beyond that. When the exposure monitoring indicates that you are at or above the PEL, we're going to keep monitoring you and make sure that we can get those limits down below the PEL. as the employer, as we get these results, we're going to communicate those to the employee and tell them, hey, there's exposure beyond the BEL. Here, doing to rectify that. That doesn't mean that employee is being exposed, but there's the potential to be. So if they're not wearing their PPE, or if they're not using Table 1, they could be being exposed unnecessarily. Like we said earlier, those medical evaluations, including x-rays and lung function tests, are available to workers at any time, but absolutely who are wearing a respirator for 30 or more days a year. And then those records we have to maintain for 30 years. Again, because silica has such a long time before you might see symptoms, we have to maintain those records to make sure that you weren't exposed 25, 30 years ago and are now suffering from lung cancer. So we want to make sure that we're keeping those records to make sure we held up our end of the deal, that we protected you, that we gave you the respirators and the HEPA filters and the training. So what did we learn? We talked about the health hazard of silica exposure, and unfortunately there wasn't any good news. Silica exposure causes lots of lung diseases: silicosis, pneumoconiosis, lung cancer, COPD. What are some of the tasks that it could expose you to silica? Grinding and cutting and demolition of drywall and mortar and bricks and sidewalk and concrete, and I mean the tasks are laid out in Table 1, and what could expose us and kind of the tasks that we perform. And looking over it, it's pretty inclusive. And then what measures does the employer have to implement to protect you from exposure to silica? Like we went over, we do the exposure monitoring. We have to have a competent person. We have to have a program. We have to have these training times and things to protect you from the exposure to silica. What is a competent person? Remember, a competent person is someone who has the knowledge and skills necessary to identify a hazard and the authority to do something about it. And then why do we want to perform these medical evaluations? Why the medical surveillance? We want to make sure you're not being exposed. And if there's a potential for overexposure, we want to tell you there's a potential and here's what we're doing about it. So, thank you. This concludes your updated online training on crystalline silica for the construction industry. For my records, please email me the time and date of completion, and your code word is Python. Depending on who you are, who you work for, and who I am to you, please send it to the appropriate email address. Thank you.